Today we want to take a look at tangents. A tangent can be defined as a line that touches the circumference of a curve at a point. Now when we say at a point, what we mean is that it doesn't cut through, but that it barely touches the circumference of a curve. And note I've said a curve and not just stuck to a circle, because as we work we will see that tangents can be applied on a variety of geometric shapes, not just circles. So I just want to make that clear, that a tangent is a line that touches the circumference of a curve at a point. Now, to help you understand that, we will just bring some things onto the sheet. So for us, first, we know that we deal with circles most of the time. So if we have a circle as is represented here, to produce this circle we would have a radius, and the radius line for a circle or the radius line for a curve becomes important to the tangent. So that radius line, we refer to that as a normal, and a normal then on a tangent would be showing you that radius line in position to allow you to represent where the tangent is going to fall. So this line here is the radius line, or a radius line for the circle, but this line also locates the point where the tangent will be drawn. So all you would do in this situation is produce a 90-degree angle at the point where this line, the red line, the normal, touches the circumference of the curve. And if you have a 90-degree angle there, then that line would be the tangent that you require. So the construction then would look something like this, indicating that this is a 90-degree angle. So something else comes out with regards to tangents, that tangents are at right angles to the locating line, which in this case is called a normal. So you bear that in mind as you work through these constructions as well. Now, something that is also important for us to note is that tangents will also have a mathematical principle. There is a mathematician called Pythagoras, and he came up with this very interesting concept. He came up with the fact that if you have a semicircle and you place a point anywhere on the circumference of that semicircle, and then you connected it to the diameter, to the ends of the center line, that you would automatically produce a 90-degree angle. Now, if I put in a triangle for you then to look at, you will see what I mean. So this triangle in here, the point would have been on the circumference, and we just connected a line here, connected a line here, then automatically the angle that we produce in here would be 90 degrees. And it doesn't matter where that line, that point falls. So that point can actually be anywhere on the circumference of the curve. You would still be producing a 90-degree angle, and in essence you'd be producing a right angle triangle, because we know that the longest side of a right angle triangle is the hypotenuse, which will be the diameter line running across here, and the 90-degree angle is always opposite to the hypotenuse. So you would be producing a right angle triangle. But it is critical to note this, and I'll just throw in another one just to make sure that we are on the same page, just from another position. So this just confirms for you that no matter where on the circumference of this curve you select a point and you make the connections, that the angle formed in here will always be 90-degree angles. And this principle is the principle which works for the construction of tangents. So you will see as we work that once we produce tangents, we are also on most of the constructions applying a principle similar to this. So there will be 5 constructions that we will explore during the course of this lesson, and those 5 constructions will form the basis for any further work that we will have to do when you're actually required to produce figures. You'll be asked to apply those constructions to come up with the solution once you're required to produce figures. So let's look at construction number 1. Construction number 1 requires you to draw a tangent from a point, and I'm representing the point here at this cross, to a circle. That's the only bit of information that you're given, and you're required to represent a tangent. Remember that the tangent will hit that circle, blend into the circumference of that circle, and we would have to locate a normal for that tangent as well. So there are certain basic things that we will be applying in most cases when we have to do these examples. One of the first things will be to connect the centers. So the point is a center, and the center of the circle represents another center. So the first thing that we would do on a construction like this is that we would look to put in the connection between centers. So this red line that is represented here would be that connection. The next step would be to bisect the distance that you have formed with that line. I'm not going through the construction for bisecting, I'll just put in the bisector. But whether you're doing this manually or you're doing it on the computer, you should be in a position at this level to bisect this line. So I'll just drop in that bisector, but we know the process with regards to producing a bisector. So this line represented here cuts that distance in half. And once you have found the center point on that line, you are then positioned to be able to draw a semicircle. So that semicircle will go into position, and once we have this semicircle, then the point of contact between the semicircle and the circle is in blue, so the outline, the final product is in blue. The tangent will be at that point of contact, which will be a point on the circumference of the curve, if you remember the explanation with regards to Pythagoras. Then you could draw in this normal from the center to that point of intersection. So this I'm representing now. It's a little light, but that line is there if you look carefully. So that is the normal, and then the tangent would just be drawn in by pulling a line from the point through the intersection, and that would be representing the tangent as required. So this then would show you the tangent as required. Now, I deliberately didn't do this on the horizontal because sometimes we make the mistake of thinking that everything that will be given will be either horizontal or vertical. So I threw the point at a slightly different angle off the horizontal to allow us to still work the steps for the construction. But the steps don't change no matter the orientation of the drawing. So bear that in mind as well as you work, because a question may come not settled in the way that you may be accustomed to seeing it, but you should still be able to apply the principles to get the construction done. So this first construction is to construct a tangent from a point to a circle. We are now on to the second construction. This construction, we have two circles. These two circles are of equal diameter. Now, once you're dealing with circles, you can have two types of tangents. You can have an internal tangent, and you can also have an external tangent. An external tangent would be touching the two circles on the outside. An internal tangent would swing between the two circles and still be blending in. So just remember that. This construction then is for an external tangent to two circles of equal diameter. So I've set up two circles. At a glance, you can see that the diameter of the circles are the same, so there's no major problem there. And just like we did on the first construction, our first step will be to connect the centers. So here, I'm just showing you the line that will connect the centers. And as we know, we connect the centers, then this one is relatively simple. There are no special constructions related to this one. This is the one that really would not be applying the Pythagoras in the same way, because all you would need to do to complete this construction, once you've connected the centers, is that you will produce a 90-degree angle to that center line, that connection line in each of the circles. And we know how to produce a 90-degree angle. We know how to construct 90 degrees. That's something that we would have done right at the start of technical drawing. And in CAD, you should also then be able to pull a line at right angles to this. So if I drop in those two normals now, because remember that the tangent will always require the normal. So if I drop in those two normals, you can see these two lines represented now at 90 degrees to the red line, or the line connecting the two centers. And then all you would do is, with a straight edge, pull a line between these 2 points of contact, and you would have the external tangent to two circles of equal diameter. So that line is in now, and that allows you to see the construction for producing the tangent. You will note that I use different colored lines. This is just for clarity, but if you are producing the drawing, you would have a standard with regards the construction lines, and you would have a standard with regards the outlines. So I'm using different line colors, so that you are able to distinguish the steps that we're following. This completes this construction, and we are now ready to move on to the third construction. This third construction is for a tangent, an internal tangent to two circles of equal diameter. So again, we have set out on the page two circles with the same diameter. And remember, we said that the internal tangent will cut between the two circles like so. So again, basic steps that will be applied on the majority of the constructions. Connect the centers, and I've put in the bisector at the same time. So we connect the centers and we bisect the distance that is formed between the centers. The next step is another bit of bisecting. So we're bisecting twice on this construction. When you have found that 1/2 of the connecting line, you want to bisect that distance as well. So the distance from one center to the center of the original line, you want to put in a second bisector. So we've cut that in half. So if this distance here happened to be 100 as we started, then when you bisected that, that distance would be 50. And then when you bisected that, that would be putting you now at 25 inside here. So this bisector, this second bisector, is the bisector that we want to use, and we're using the center point that we have formed here to now draw a semicircle at the bottom. So this, as I'm representing now, would be that semicircle. So we have this semicircle in place, and we now want to locate the normal for the tangent. You're always locating the normal, and remember that the normal is a radius line. So in this case, the normal would be from the center of the circle to the point of intersection between this semicircle and the main circle that we started out with. I'll just show you that normal in position. And this normal here then would be locating the tangent. Now, because it's an internal tangent, you would need to produce a normal on the opposite side. If you were using the drawing instruments, you would be taking your set squares and you'd be sliding to get the parallel line up the other side. Here you can take the line and transfer it over to the other circle. A variety of ways you can copy. You can take the angle and move the angle over, but you would produce a line parallel on the second circle on the opposite side to allow you then to locate the tangent. And this is the point of contact for the tangents. So all you would be doing is taking a straight edge if you were doing a manual drawing, or you would just be pulling that line to connect the 2 points to give you the tangent on this drawing. This is an internal tangent, tangent swinging between the two circles to two circles of equal diameter. Construction number 4 we'll now be dealing with circles of unequal diameter. So we have a big circle and we have a small circle. And for this construction, I'm just going to reference dimensions because it will also help you to understand a little bit better. So we're dealing with radius all the time. So let's say that this big circle had a radius of 60 millimeters. Let's say that this small circle had a radius of 25 millimeters. We are following the same basic steps. So as usual, our first step will be to connect the centers and bisect the distance formed. Once you have done that, you need to now get a semicircle on this line. So I'll just drop in that semicircle so that you can see it in position. So this now is the semicircle that you require. Now here is where you have to be very, very careful. We are taking the radius of this smaller circle. This smaller circle has a radius of 25 millimeters. So if you were drawing, you would open your compass to 25 and you would take that radius and you would mark that radius inside of the bigger circle. So you would start on the outside by the circumference here and you would drop that radius inside of the bigger circle. So once that is done, you have an arc or a little curve at that point. So this is 25 millimeters in here. In essence, what you're doing is subtracting the radius of the smaller circle from the radius of the bigger circle. So that now gives you the opportunity to produce another circle on this drawing. That circle will be from the center of the big circle to the point where you marked off the 25 millimeters. So if you took away then 25 from 60, you would be left with 35. So the radius of this new circle that I'm representing here is 35 millimeters. This new circle will be used to give you the normal for the tangent. So the normal is a line taken from the center of this circle passing through the intersection between the big semicircle and the new circle, but extending to the original circle, because remember the tangent is to the circle on the outside. So this line must pass through the intersection. That is what is most critical, and then extend out to meet the original circle. So I'll just drop that in to show you it in position. So this is what that normal would look like. Note that it passes through the intersection here, but it extends out to the main circle, and it is an external tangent. So the normal for the second circle would be on the same side and the same plane as the first circle. So again, that's a parallel line. So if we drop in that parallel line, then you would have that second normal in position, and then the tangent would be connecting these points of intersection as I have done now, and this would be an external tangent to two circles of unequal diameter. The final construction, very similar to this, is for an internal tangent to two circles of unequal diameter. We are almost following the same steps, just that we make an adjustment towards the end. So if we look now for this construction, it starts out in much the same way. We're using the same dimensions, so big circle, radius 60, small circle, radius 25. The steps go in much the same order. So again, you connect the centers, you bisect the distance between the centers, and you draw that semicircle in position. Now this is where the little change is. On the previous construction, we subtracted the radius of the small circle from the radius of the big circle. For this one, to give you the internal tangent, we are adding the radius of the small circle to the radius of the big circle. So this is 25 again. So we're going to take that 25 now and we're going to add it on out here. So we'll end up producing a bigger circle on this construction. So let's just show what we would have done. We would have marked off that 25 radius. So now we can open our compass from the center. If we were doing a manual drawing in CAD, you would now drop in a new circle equal to this distance, which should be 25 plus 60. So that would be 85 for that distance. So that radius of the big circle that you're going to produce. And you will drop in now that new circle. So that circle is there now showing on the outside. We now have to seek to locate the normal for the tangent. So the normal now is a line going from the intersection of the big semicircle and the big circle, from that intersection on the outside that I'm highlighting here to the center of your original circle. The normal will be coming down that distance, but then you are only concerned with it at this point on the original circle. So if I drop in that normal for you now, you would see that line coming all the way through, but in essence you're concerned with the intersection right here on the blue circle, and you need to get a line now parallel to this, but that parallel line will fall on the other side. So if I show you that new normal, it is now going down on the opposite side to allow you to get the internal tangent. And just to complete, you connect the points of intersection formed, and this would be an internal tangent to two circles of unequal diameter. Questions will come where you will be presented with a shape, presented with a figure, and you're asked to produce the figure. To produce the figure, you will first have to isolate. You will have to look at the figure and determine what is happening. The figure may not give you a full circle. You may see semicircles and straight lines connecting them. So in that regard, if you have a semicircle, that's a radius. So a semicircle can be a complete circle when you think about it. So once you can identify what is happening on the drawing, if your drawing has 3 circles, you isolate 2 and say, well, what kind of tangent connects these 2 circles? Is this an external tangent? Is this an internal tangent? And then you're able to do the appropriate construction between those 2 circles. And then you move to the next. What type of tangent connects these 2 circles? And you would then be able to apply each construction depending on what is required for that portion of the drawing. The process is relatively simple. We just need to be reminded all the time about the constructions. So we would have gone through to produce a tangent from a point to a circle, to produce an external tangent to 2 circles of equal diameter, to produce an internal tangent to 2 circles of equal diameter. We produce then an external tangent to 2 circles of unequal diameter, and we closed off with an internal tangent to 2 circles of unequal diameter. This is the point where we will close off this session for today. I have truly enjoyed bringing this to you, and I will be back soon to continue in this sequence of presentations for geometric constructions.